in last lecture we had started with similitude. Okay, so first of all we had seen what is the difference between model and prototype. Okay, so model is nothing but it is a small scale replica of the actual machine. Okay, actual machine or mechanism or any structure, that is called as model, and the real size machine which is built, that is called as prototype. Okay, so in R&D, first of all, one model is prepared, testing is done on model, and if we get the desired result, then first prototype is built. Okay, and then actual working is observed. So in this way, R&D is done in different companies. Okay, then similitude is nothing but it is the method of establishing the relation between the model and prototype in every aspect. Okay, therefore in similitude, any model or prototype, it is supposed to satisfy three types of similarity. So first is geometric similarity, second is kinematic similarity, and third is dynamic similarity. All this we had seen. Okay, then in geometric similarity, basically the ratios of dimensions, that is length, diameter, width, height, area, volume of prototype and model, okay, they are considered. So in kinematic similarity, the velocity acceleration of model and prototype are considered, while in dynamic similarity, the forces, okay, like inertia force, viscous force, gravity force, pressure force, and so on, they are considered. The ratio of prototype and model are considered. Okay. After that, we had seen the different types of forces which are acting on any uh, fluid flow or any body. So the six type of forces acting on the fluid or acted by the fluid on any body. They are inertia forces, viscous forces, gravity force, pressure force, surface tension force, and elastic force. Okay. After that, we had seen. I had told you to remember this sequence. If you remember this sequence, okay, so you can remember the definitions. Okay. So first dimensionless number is Reynolds number. So it is a ratio of inertia force to viscous force. In numerator, always there is inertia force, and in denominator, the forces are changing. So ratio of inertia force to viscous force, Reynolds number. It is denoted by Re. So Re equals to rho VL by mu, or rho V D by mu, where D is diameter of pipe. Okay, or VD by nu. This derivation we had seen. Then second is Froude number. So Froude number, it is the ratio of the square root of the inertia force to gravity force. Okay, so mathematically it is given by Fa equals to V upon root of Lg. So derivation we had seen. And Euler's number, it is defined as the square root of the ratio of the inertia force to pressure force. Okay, so it is Eu equals to V upon under root of P by rho. Then Weber number, it is defined as the square root of the ratio of inertia force to surface tension force. Okay, and mathematically it is given by W equals to V upon under root of sigma by rho L. Okay, and last is Mach number. So Mach number is nothing but it is the square root of the ratio of the inertia force to elastic force. Okay, so it is V Mach number m equals to V upon under root of k by rho. Here, this term k by rho, it is also called as velocity of sound. Okay, or simply called as sonic velocity. So m equals to actual velocity of flow divided by sonic velocity. This is another definition. After that, we had started with the Model's law. Okay, so first model law which we had seen in last lecture, that is Reynolds model law. So Reynolds model law simply states the Reynolds number of model and prototype, they should be equal. Okay, so Reynolds number of model, it should be always equal to Reynolds number of prototype. Okay, so rho m Vm Lm upon mu n, that equals to rho p Vp Lp upon mu p, where m denotes properties for model, p denotes property for prototype. Okay, now taking the ratios, this rho p divided by rho m, Vp divided by Vm, Lp divided by Lm, and 1 upon mu p divided by mu m. So we will have density ratio into velocity ratio into length ratio divided by viscosity ratio. This should be equals to 1. Okay, so this is nothing but Reynolds model's law. Then from Reynolds model law, we can also have other ratios. Okay, such as time ratio or scale ratio for time. So time scale ratio is TR equals to L upon VR. We know velocity equals to length upon time. So time equals to length upon velocity. Okay, therefore time ratio equals to length ratio upon velocity ratio. Okay, similarly acceleration ratio is velocity upon time, so VR upon TR. Okay, similarly force ratio, okay, it is mass into acceleration, so it is rho r LR square VR into AR. And discharge is rho AV. So discharge ratio is density ratio into area ratio into velocity ratio square ratio. Okay, so all this I think we had completed, and we had seen one problem in last lecture. So today we are going to complete the remaining laws, and your unit number 6 will be over. Okay, so next law which we are going to see, that is Fraud's model law. So Fraud's model law, it states, or it simply states, the fraud number for model and for prototype, it should be equal. Okay, so basically the fraud model law is a law which in which the models are based on fraud number. Okay, which means for dynamic similarity between the model and prototype. Basically fraud model law is applicable in a special cases of flow. Okay, where the dynamic similarity plays a very important role. Okay, so it simply states the fraud number for both model and prototype, it should be equal. The fraud model law is applicable when gravity force is predominantly affecting the flow. Okay, for example you can say flow through मराठीत म्हणतो ना झरना. Okay, तर basically what is happening in waterfall, water is falling from a particular height, so all the flow of the water is completely controlled by your gravity. So suppose you want to place a turbine. Okay, तुम्ही त्या झरण्यात तुम्हाला सपोज टर्बाइन इन्स्टॉल करायची आहे, तर त्या केसमध्ये वॉट एव्हर द इनपुट एनर्जी और काइनेटिक एनर्जी दैट इज गवर्न बाय ग्रेविटी. ओके, तो जो भी फ्लूइड का एनर्जी रहेगा, हाइड्रोलिक एनर्जी, इट विल बी गवर्न बाय ग्रेविटी. So in such type of model, fraud model law plays a very important role. Okay, so this law is applicable when the gravity forces are affecting the flow. Okay, so mathematically the fraud laws states the fraud number of model, it should be equals to fraud number of prototype. Okay, so basically there are different applications where fraud law is applicable. For example, free surface flow over spillway, weirs, sluice channels. Okay, then flow object from an orifice or nozzle, then where waves like are likely to be formed on surface. So these are the example where fraud law is applicable. So let Vm is the velocity of fluid in model, Lm is the linear dimension of model, and Gm is the acceleration due to gravity in model where the model is tested. Okay, similarly Vp, Lp, and Gp, they are the corresponding velocity, length, and acceleration due to gravity for prototype. And as per fraud law, the fraud number for model, it should be equals to fraud number for prototype. Okay, therefore Vm upon under root of Gm Lm, it should be equals to Vp upon under root of Gp Lp. Now we will divide this Vm on right side, so Vm upon Vp divided by Gm Lm, we will divide here, so under root of Gm Lp divided by Gm Lm. Okay, so finally we will have, or we can have this Vr. Okay, 1 minute. Okay, इनको डिवाइड करने के बाद Vp upon Vm. Okay, similarly यहाँ पे Gp upon Gm of Lp. Okay, so this ratio Vp by Vm, this is nothing but velocity ratio. So this velocity ratio divided by under root of length ratio into gravity ratio. Okay, so this should always be equal to 1. Okay, now acceleration due to gravity for prototype and model, basically दोनों अर्थ पे टेस्ट हो रहे हैं. ओके, कभी आप ऐसा कर रहे हो कि प्रोटोटाइप मून पे टेस्ट करना है और मॉडल अर्थ पे टेस्ट करना है, जैसे हमारे जो रॉकेट्स होते हैं, तो उस केस में जी दोनों का अलग रहेगा. बट नॉर्मली हम जो भी मशीन बनाते हैं अर्थ के लिए बनाते हैं, सो उस केस में एक्सेलरेशन ड्यू टू ग्रेविटी 9.81 रहेगा दोनों केस में. तो उस केस में सिंपली Vr अपॉन अंडर रूट ऑफ Lr रहेगा. ओके, सो वी कैन से Vm upon under root of Lm, that equals to Vp upon under root of Lp. Okay, So we can divide this on right side. So Vm upon Vp into under root of 1 upon Lm upon Lp, that equals to 1. Okay. So we can say Vp by Vm that equals to under root of Lp by Lm. हमने क्या किया, ये टर्म को इधर डिवाइड कर दिया, मल्टीप्लाई कर दिया, सॉरी ये टर्म को इधर मल्टीप्लाई कर दिया. So Vp by Vm that equals to under root of Lp by Lm, and Lp by Lm is nothing but velocity ratio. Okay, sorry, length ratio. Here Lr is length ratio and Vp by Vm is velocity ratio. Okay, so finally we have Vr equals to under root of Lr. So this is nothing but mathematical expression for fraud law. Okay, after that, scale ratios for different physical quantities. The first is scale ratio for time. So we know time equals to length upon velocity. Therefore, time ratio that equals to time ratio is nothing but time of prototype, or whatever the time taken by prototype divided by time taken by model for a particular case. Okay, so यहाँ पे time of prototype को हम replace करेंगे length of prototype on velocity of prototype. Similarly, time of model, it is nothing but length of model divided by velocity of model. Okay, so it will be Lp by Vp divided by Lm by Vm. Now we can rewrite this. Okay, अभी इसको numerator में ले जाएंगे तो inverse हो जाएगा. So it will be Lp by Lm into Vm by Vp. Okay, Vm ऊपर चले जाएगा, so हम Vm को ऊपर ले रहे हैं, Vp को नीचे ले रहे हैं, और ये Lm denominator में आ जाएगा. So Lp upon Lm. Okay, so this is nothing but length ratio, and this is 1 upon velocity ratio. Now we know 1 upon velocity ratio. Okay, velocity ratio is root of Lr, so it will be 1 upon root of Lr. Finally, root will cancel with this, so we will have under root of Lr. Okay, so time ratio is nothing but it is under root of Lr. Velocity ratio is also under root of Lr. Therefore, we can say velocity ratio equals to time ratio. Okay, after that, scale ratio for acceleration. So we know acceleration equals to velocity per unit time. Okay, therefore acceleration is nothing but acceleration of prototype upon acceleration of model. So it is velocity of prototype upon time of prototype divided by velocity of model upon time of model. Okay, अब इसको हम न्यूमरेटर में लेंगे. तो न्यूमरेटर में लेते टाइम ये डिनोमिनेटर में जाएगा और ये न्यूमरेटर में जाएगा. Okay, so we will have root of Tm upon Vm, sorry, Tm upon Vm. After that, we can rearrange this. So Vp divided by Vm. Okay, Vp by Vm into Tm by Tp. Okay, इसको हमने rearrange किया. So this is nothing but velocity ratio, and this is 1 upon time ratio. Okay, so 1 upon time ratio is root of Lr, and velocity ratio is also root Lr. Okay, यहाँ पे हमने derive किया. So it is root Lr multiplied by 1 upon root Lr. So root Lr cancel. So that equals to 1. Okay, therefore acceleration ratio equals to 1. That means acceleration of prototype divided by acceleration of model is equal to 1. Okay, therefore acceleration due to prototype is always equals to acceleration due to model. Okay, or we can say this acceleration here, gravity is playing the role, so acceleration due to gravity Gp that equals to acceleration due to model Gm. Okay, after that, next is scale ratio for discharge. So we know discharge is nothing but product of area into velocity. Okay, here area is nothing but length square, and velocity is length upon time. So it is L cube by T. Okay, therefore discharge ratio. So discharge ratio is nothing but discharge of prototype upon discharge of model. So it is L cube by T for prototype divided by L cube by T for model. Okay, so इसको हम rearrange करेंगे. So यहाँ पे ऊपर जाने के बाद न्यूमरेटर में टाइम ऊपर चले जाएंगे और लेंथ क्यूब ऑफ मॉडल नीचे रहेंगे. Okay, so after rearranging, we have length of prototype upon length of model whole cube multiplied by Tm numerator में जाएगा. So it is Tm divided by Tp. Okay, so this Lp by Lm is nothing but length ratio. So length ratio whole cube, and Tm by Tp is 1 upon Tp by Tm. So 1 upon Tp by Tm is nothing but time scale ratio. Okay, so it is 1 upon TR. So 1 upon TR क्या होता है? Root LR होता है. अभी हमने ऊपर देखा. Okay, so it is LR cube divided by 1 upon root LR. Okay, so finally we will have under root of LR to the power 2 by 2.5 or 5 by 2. Okay. After that, next is scale ratio for force. So scale ratio for force. Force is nothing but mass into acceleration. Okay. So mass is nothing but mass density into volume. Okay. So rho into L cube divided by acceleration. Acceleration is change in velocity per unit time. So velocity upon time. Okay. So we can rearrange this as rho L cube. So L cube is L square into L. So rho L square into L upon T. Okay. Into V. Okay. So we will have finally rho L square as it is, and length upon time is velocity. Okay. So velocity into velocity square. So rho L square V square. Okay. So scale ratio for force. So first of all हमने force निकाला. So force is nothing but rho L square V square. Okay. Therefore scale ratio for force is nothing but Fr. So Fr is force of prototype divided by force of model. Okay. So put the value of force. So it will be rho of model prototype into LP square into VP square divided by density of model into length of model whole square into velocity of model whole square. So rho P L square VP square upon rho M LM square VM square. Okay. So this is rho P by rho M. So this is nothing but density ratio. LP by LM whole bracket square. This is length ratio, and VP by VM. This is velocity ratio. And we know velocity ratio equals to root of LR. Okay. So density ratio rho P by rho M. Suppose same fluid is used. Means for example turbine बना रहे हो. टर्बाइन में आप मॉडल में भी वाटर यूज कर रहे हो और एक्चुअल टर्बाइन जो रहेगा प्रोटोटाइप उसमें भी वाटर यूज करने वाले हो. तो उस केस में डेंसिटी विल बी सेम. ओके. वाटर का डेंसिटी 1000 है, मॉडल में भी 1000 रहेगा और प्रोटोटाइप में भी 1000 रहेगा. सो इन दैट केस if density if fluid is same, so this density ratio is 1. Okay. Therefore force ratio क्या रहेगा LP by LM whole bracket square into VP by VM whole square. So it will be LR square into VP VR square. VR क्या होता है root LR. So root LR whole bracket square. So square और ये cancel होगा. So we will have LR square into LR. So it is LR cube. Okay. Then next is scale ratio for pressure intensity. Okay. So scale ratio for pressure intensity. So we know pressure P equals to force upon area. So it is rho L square V square upon L square. L square cancel. So it is rho V square. Okay. Therefore pressure ratio is pressure of prototype divided by pressure of model. So it is rho P into VP square divided by rho M into VM square. Okay. Again, density of model and prototype are same if fluid is same. Okay. Therefore it is simply VP square by VM square. So VP by VM whole bracket square, that means velocity square. And we know velocity ratio square is root of LR whole bracket square. So यहाँ पे square और square root cancel होगा. Finally we will have LR. So pressure ratio equals to LR. Okay. Similarly, we can have scale ratio for work, energy, and torque. Okay. So we know torque is nothing but force into distance. So F into L. Okay. अभी L आपको already पता है. Okay. So torque ratio is nothing but torque of prototype divided by torque of model. So F into L of model prototype divided by FL of model. So F of prototype upon F of model is force ratio. Length of prototype upon length of model is length ratio LR. अभी यहाँ पे FR already आपने derive किया. It is LR cube. So LR cube into LR. So it is LR to the power 4. Okay. See, as far as आपको ये डेरिवेशन याद नहीं रखने, बट सिंपल डेरिवेशन है, आप इसको लॉजिकली याद रख सकते हो. ओके. सो आप इसको 2-3 बार प्रैक्टिस करोगे घर पे तो आपको याद हो जाएंगे. एंड इसके ऊपर एमसीक्यूज आ सकते हैं. ओके. सो रिमेंबर दे कैन आस्क यू लाइक दिस द in Weber model. Okay. In Weber model the force ratio is given by, there will be four option: LR, LR square, LR cube, LR to the power 4. Okay. So answer will be LR cube, force ratio. Okay. Or the scale ratio for pressure intensity is given by, there will be 4 option: PR equals to LR, PR equals to LR square, PR equals to LR cube, PR equals to LR to the power 4. आंसर विल बी PR इक्वल्स टू LR। तो आपको ये रिलेशंस MCQ में पूछ सकते हैं, MCQ के फॉर्म में। ओके, तो आपको ये थोड़ा अच्छे से करना है। आफ्टर दैट नेक्स्ट इज numericals, or we will see one numerical on Weber law. So a ship model of scale 1:50. ओके, अभी स्केल 1:50 का मीनिंग क्या हुआ कि सपोज आपका जो लेंथ है, आपका प्रोटोटाइप का लेंथ है वो 1 मीटर है। ओके, तो आपका जो मॉडल रहेगा उसका लेंथ कितना रहेगा, 1/50। सपोज 2 मीटर है तो यहाँ पे 2/50, 3 मीटर है तो 3/50। ओके, तो आप उसको स्केल डाउन कर रहे हो। ओके, so that scale is 1:50. So a ship model of scale 1:50 is towed through seawater. Okay, at a speed of 1 meter per second. ओके, दैट मीन्स एक शिप है, शिप खराब हो गई है। ओके, और आप क्या कर रहे हो कि वो जो शिप का जो मॉडल है उसको टो करके ला रहे हो, मतलब दूसरे शिप से आप विद द हेल्प ऑफ एनी रोप और समथिंग यू आर टोइंग इट। ओके, एंड कितने स्पीड से टो कर रहे हो, एट अ स्पीड ऑफ 1 मीटर पर सेकेंड। द फोर्स ऑफ 2 न्यूटन इज रिक्वायर्ड टू टो द मॉडल। सो जो भी मॉडल है उसको टो करने के लिए कितना फोर्स अप्लाई करना पड़ता है, उसको खींचने के लिए 2 न्यूटन। ओके, determine the speed of ship and propulsive force on the ship if the prototype is subjected to wave resistance only. Okay, हमें यहाँ पे शिप का स्पीड और प्रोपल्सिव फोर्स निकालना है। ओके, किसके लिए, प्रोटोटाइप के लिए, बिकॉज यहाँ पे आगे हमें कंडीशन दिया है इफ प्रोटोटाइप इज सब्जेक्टेड टू वेव रेजिस्टेंस। सो फर्स्ट ऑफ ऑल ये जो रेशियो है 1/50, तो ये बेसिकली आपका ज्योमेट्री, जैसे मैंने बताया कि 1 मीटर एक्चुअल प्रोटोटाइप का लेंथ है, तो उसके मॉडल का कितना रहेगा 1:50। ओके, सो बेसिकली फ्रॉम द स्केल रेशियो वी विल हैव LR इक्वल्स टू 50। ओके, सी मैंने बताया था कि आपका सपोज आपका जो एक्चुअल प्रोटोटाइप है, प्रोटोटाइप 1 मीटर का है, तो मॉडल का लेंथ कितना रहेगा 1/50। सपोज इसका प्रोटोटाइप का लेंथ 50 मीटर है, तो मॉडल का कितना रहेगा, मॉडल का 50 इंटू 1/50, 50 इंटू 1/50 मतलब 1 मीटर रहेंगे। ओके, अभी हमारा लेंथ रेशियो क्या होता है, लेंथ रेशियो इज लेंथ ऑफ प्रोटोटाइप डिवाइडेड बाय लेंथ ऑफ मॉडल। तो आप यहाँ से कोई भी रेशियो ले लो, यहाँ पे सपोज 1 मीटर लिया, प्रोटोटाइप को 1 मीटर अज्यूम किया, तो मॉडल का कितना होगा 1/1/50। तो बेसिकली 50 न्यूमरेटर में चले जाएंगे। या फिर आपने 50 मीटर अज्यूम किया, तो मॉडल का कितना रहने वाला है 1 रहने वाला है, सो 50:1। ओके, देयरफॉर लेंथ रेशियो इज 50:1 और simply 50. Okay, then velocity of model is 1 meter per second and force of model is 2 Newton. So we will assume let whatever the velocity or speed of the ship is VP and propulsive force on the ship, actual prototype, that is FP. Okay, so as prototype is subjected to wave resistance only, therefore for dynamic similarity the fraud number of model and prototype it should be same. Okay, अभी यहाँ पे एक्चुअली वेव बोला है। ओके, आपको ये 3 पॉइंट याद रखने हैं। हमारे मॉडल फ्रॉड लॉ कब यूज होता है, फ्रॉड लॉ व्हेन फ्री सरफेस फ्लो, जो आपका फ्लो है दैट इज फ्री सरफेस फ्लो सच एज रिवर, स्पिलवे, वियर्स, रियर्स, स्लुइस गाइड्स, चैनल्स, यहाँ पे। देन सेकेंड आपका जो ओरिफिस नोजल से फ्लो होता है, और तीसरा केस वेव, जब वेव का फ्लो होता है तो हम फ्रॉड लॉ यूज करते हैं। और न्यूमेरिकल में हमको क्या बोला है, न्यूमेरिकल में बोला है कि इट इज सब्जेक्टेड टू वेव रेजिस्टेंस। तो वेव रेजिस्टेंस आगे इसका मतलब है फ्रॉड लॉ यूज करना है। ओके, तो एज वेव रेजिस्टेंस इज देयर, देयरफॉर वी आर गोइंग टू मेक द यूज ऑफ फ्रॉड लॉ। So we know as per fraud law, Vp by Vm, that means velocity of prototype upon velocity of model, velocity ratio, that equals to root LR, ऊपर हमने derive किया था, so that is √50. Okay, therefore velocity of prototype is √50 times velocity of model, so it is √50 into 1, so it is √50, that is 7.071 meter per second. Okay. After that, force ratio. So force ratio हमने निकाला था, it is cube of LR. Okay. So FR equals to FP by FM, that is cube of LR. So it is cube of root 50. So 50 root 50. Okay. So it is force of model. Force of prototype is LR cube into force of model. Okay. So force of model is 2 Newton. Okay. और यहाँ पे रूट 50 है, एक्चुअली यहाँ रूट 50 दिखाना रह गया है. So it is root 50 whole cube. Okay, root 50 whole cube. So you can take 50 root 50 into 2. So it is 25000 Newton. Okay. So now we are going to see our next model law, that is Euler's model law. Okay. So Euler's model law basically this model law is mostly applicable between the prototype and model, where dynamic similarity between model law is applicable in. Okay, now the flow, where the Euler's number, it is playing a very important role. Okay, now we had defined Euler's it is a square root of the ratio of inertia force to pressure force. Okay, so the flow, where the pressure force is playing a very important role. For example, flow through pipe or flow through siphons. Okay, or whatever the transport of fluid. Okay, so in such cases, basically Euler's model law is applicable, and it simply states the Euler's number of model and prototype, it should be equal. Okay, so basically according to this law, we can say Euler's law of model that equals to Euler's law of prototype. Okay, therefore if we assume Vm is the velocity of fluid in model, Pm is the pressure of fluid in model, and ρm is the density of fluid in model. Okay, similarly Vp, Pp and ρp, they are the corresponding pressure, velocity and density in prototype. Then as per the Euler's model law, Vm upon root of Pm upon ρm, that equals to Vp upon under root of Pp upon ρp. Now here ρm and ρp, they are the density of fluid. So if both the fluids are same, in that case ρm equals to ρp. So simply we will have Vm upon root Pm, that equals to Vp upon root Pp. Okay. Now remember, the Euler's model law is applicable for flow problems where flow is taking place or pressure is playing a very important role. For example, closed pipe. Okay, in which turbulence is fully developed. Okay, and viscous forces are negligible, and gravity and surface tension forces are absent. Okay, and in such cases even cavitation can also take place. So in such type of flow, basically Euler's model law is applicable. Now the next model law which we are going to see, that is Weber's model law. Okay, so Weber's model law, it plays a very important role whenever the surface tension force is going to play an important role. Okay, so suppose flow is taking place in the form of very thin sheet. Okay, surface tension कहाँ पे होता है, एक छोटी सी लेयर पे होता है, that is near the liquid surface. So basically जब आपका flow होता है उस टाइम पे जो layer surface is very very small. So in that case Weber model law is playing a very important role. Okay, so the Weber law, model law is a law in which the models are based on Weber number. Here the Weber number is the ratio of the square root of the inertial force to surface tension force. So as per this law, the dynamic similarity between the model and prototype is same. Okay, or the Weber number of model and prototype is same. According to this law, Weber number of model, it should be equals to Weber number of prototype. Here W is nothing but Weber number, which is given by V upon under root of sigma by rho L. Okay, therefore we can say if Vm is the velocity of fluid in model, sigma m is the surface tension of the fluid in model, rho m it is the density of fluid in model, model, and LM is length of the model. Okay. Similarly, BP, rho p, sigma p, and LP, they are the corresponding velocity, surface tension, density, and length of prototype. Okay. Therefore, as per this law, Vm upon sigma m upon Vm upon under root of sigma m divided by rho m Lm, that equals to Vp divided by under root of sigma p divided by Lp rho p. Now, if the fluids are same, okay, then this rho p and rho m can be cancelled. Okay, so this is nothing but Weber model law. Then the last model law which we are going to see, that is Mach model law. Okay, so this Mach model law is basically concerned with compressible forces where or compressible flow. Okay, so elastic forces. Mach number is nothing but it is the ratio of square root of inertia force to elastic force, and this elastic force plays an important role in compressible flow. In case of incompressible flow or liquids, it is not playing important role. Okay, therefore Mach model law is applicable where gaseous flows are taking place. Okay, so uh, as per the Mach model law, the Mach number of model and prototype, it should be equal. Therefore, according to this law, Mach number of model, it should be equals to Mach number of prototype. Okay, here Mach number is ratio of actual velocity divided by k by rho. Therefore, if Vm is the velocity of fluid in model, Km is the elastic forces, okay, or bulk modulus for model, and rho m is density of fluid in model. Similarly, Vp, Kp, and rho p, they are the corresponding velocity, bulk modulus, and density of the fluid for prototype. Then, as per this law, Vm upon under root of Km rho m, okay, Km divided by rho m, that equals to Vp divided by under root of Kp upon rho p. So if the fluids are same, so rho m, rho p are same, so you can cancel them. Okay. So we will see one last numerical, and we will complete our unit number 6. So the pressure drop in an aeroplane model of size 1/10 of its prototype. Okay, so model का size कितना है? 1/10 of the prototype. Okay, is 80 Newton per meter square. So pressure drop is 80 Newton per centimeter square. और यहाँ ये कहाँ पे हो रहा है? मॉडल के लिए हो रहा है. Okay, so that is pressure of model. The model is tested in water. Find the corresponding pressure drop in its prototype. Take the density of air as 1.24 kg per meter cube, and the viscosity of water is 0.01 poise, while viscosity of air is 0.0018 poise. Okay, that means आपको एक एरोप्लेन डिजाइन करना है. एरोप्लेन कहाँ पे फ्लाई होने वाला है? जो एक्चुअल प्रोटोटाइप है वो एयर में फ्लो होने वाला है, बट आपने जो उसका मॉडल बनाया है, ओके, सो दैट मॉडल इज टेस्टेड इन वाटर. मतलब आप मॉडल को वाटर में टेस्ट कर रहे हो और एक्चुअल एयरप्लेन एयर में फ्लो होने वाला है. ओके, सो बेसिकली जब हम वाटर में उसको टेस्ट कर रहे हैं तो कितना प्रेशर ड्रॉप हो रहा है? 80 न्यूटन पर सेंटीमीटर स्क्वायर. ओके, सो pressure of model is 80 Newton per centimeter square. So convert Newton per centimeter square into Newton per meter square. So multiply by 10 to the power 4. So it is 80 into 10 power 4 Newton per meter square. Okay. Then length ratio. Yeah. Again, यहाँ पे क्या बोला है? Model 1/10 है. Okay. So suppose aeroplane का height 1 मीटर है. Okay. Prototype का, तो model का कितना रहेगा? 1/10. ओके, ये मॉडल करेंगे. सिमिलरली सपोज प्रोटोटाइप 10 मीटर का है, तो मॉडल का कितना रहेगा? 1/1/10. सो इट इज 1/1/10. सो इट इज 1. ओके, सो हमारा लेंथ रेशियो क्या होता है? लेंथ रेशियो इज लेंथ ऑफ प्रोटोटाइप डिवाइडेड बाय लेंथ ऑफ मॉडल. ओके, सो लेंथ ऑफ प्रोटोटाइप 10 मीटर divided by length of model 1 meter. So 10/1. So finally, sorry, 10/1. So यहाँ पे 10 होना चाहिए था. There is some printing mistake. Okay, so it is 1/10. So length ratio 10 रहेगा. Okay, then fluid in model में water है और prototype में air है. viscosity of water. Okay, water कौन सा मॉडल है? So basically mu m 0.01 twice. You can convert it in Newton second per meter square divided by 10. Then density of water is 1000. Density of air is 1.04 1.24 kg per meter cube. So ये हमारा प्रोटोटाइप है. So rho p and then viscosity of air. So air हमारा प्रोटोटाइप है. So mu p is 0.0018 twice. Okay. So हमें प्रेशर ड्रॉप कहाँ पूछा है प्रोटोटाइप में, सो उसको हम अज्यूम करेंगे लाइक पीपी इज द प्रेशर करस्पॉन्डिंग प्रेशर ड्रॉप इन प्रोटोटाइप. तो एज द प्रॉब्लम इन्वॉल्व्स प्रेशर फोर्सेस. ओके, सो बेसिकली यहाँ पे प्रेशर फोर्स भी प्ले करने वाला इंपॉर्टेंट रोल. विस्कोसिटी भी आप देख सकते हो, विस्कोसिटी दिया है. ओके, यहाँ पे विस्कोसिटी भी इंपॉर्टेंट रोल प्ले करेगा. ओके, हेंस हमें प्रेशर के कारण कौन सा नंबर देखना पड़ेगा? यूलर्स मॉडल. And viscosity के कारण Reynolds model. Therefore, the dynamic similarity between the model and prototype, okay, considering Euler number and Reynolds number should be considered. Okay, so first of all आप कोई भी एक मॉडल सेलेक्ट करो. पहले हम सपोज Reynolds मॉडल यूज करते हैं. तो making first of all Reynolds numbers equal. So first of all we will have Reynolds number of model. It should be equal to Reynolds number of prototype. Therefore, rho m Vm Lm upon mu that equals to rho p Vp Lp अपॉन म्यू पी. ओके, तो यहाँ पे हमें वेलोसिटी रेशियो मिल जाएगा बिकॉज रो एम दिया है, रो ऑफ एयर एंड वाटर दिया है. सो डेंसिटी रेशियो हमें पता है. ओके, देन लेंथ भी दिया है, उनका लेंथ रेशियो पता है, विस्कोसिटी पता है, हमें वेलोसिटी नहीं दिया है. ओके, सो वी विल हैव Vp Vm अपॉन Vp दैट इक्वल्स टू रो पी बाय रो एम Lp बाय Lm म्यू पी म्यू एम बाय म्यू पी. ओके, इसको हमने क्रॉस मल्टीप्लाई किया है. देन पुट द करस्पॉन्डिंग वैल्यूज. Okay, so rho p by rho n 1.02 divided by 1000. Similarly, length ratio, okay, 40 दिया है. I think यहाँ प्रॉब्लम में गलत हो गया है. Okay, प्रॉब्लम में 1/40 था. Make one correction, क्योंकि वहाँ प्रॉब्लम में हर जगह 40 यूज किया है, so यहाँ पे शायद 1/40 था. Okay, so length ratio is 40. Then viscosity का भी दिया है 0.01 poise divided by 0.0018 poise. So put all these values. So Vm by Vp is 1.25 divided by 1000 into 40 by 1 into 0.01 divided by 0.0018. So solving this in calc, it is 2.755. Okay, 1 minute. Okay, so solve this on calc. On solving this on calc, it comes out to be 2.755. After that, so हमें velocity ratio मिल गया using Reynolds model law. Now we will use Euler's model law. So as per Euler's model law, whatever the ratio of Vm, okay, or Euler's number of model and prototype are same. Therefore, Vm upon under root of Pm by rho m that equals to Vp upon under root of Pp by rho p. So we can rearrange this. So Vm by Vp हमने Vp को यहाँ डिवाइड किया. अरे मॉडल का जो रेशियो है इसको हम इधर रो Pm by रो m इसको मल्टीप्लाई करेंगे. सो अंडर रूट ऑफ रो m by रो p डिवाइडेड बाय अंडर रूट ऑफ रो p by रो m. इसको हम रीअरेंज कर देंगे. ओके, सो ये प्रेशर रेशियो Pm by Pp हो जाएगा, अंडर रूट ऑफ Pm by Pp. और ये डिनोमिनेटर में होने के कारण इसका इनवर्स हो जाएगा. सो इट इज रो p by रो m. ओके, सो रो p by रो m डेंसिटी रेशियो. ओके, ये आपको डेंसिटी रेशियो ऑलरेडी दिया है, डेंसिटीज दी है, एंड वेलोसिटी रेशियो आपने ऊपर फाइंड आउट कर दिया. इट इज 2.755. सो Vm by Vp is 2.775 एंड रो p by रो m, रो p कितना है 1.24 एंड रो m कितना है 1000. So putting these values, okay, so 2.755 that equals to under root of Pm by Pp into under root of 1.24 divided by 1000. So ये कैलसी पे सॉल्व करने के बाद it comes out to be 0.0352. So divide this with 2.755. Okay, so it comes out to be 78.267. Then squaring both sides. So it will be Pm by Pp that equals to 78.267 whole bracket square. Okay, अभी I think आपको प्रेशर ऑफ मॉडल दिया है, सॉरी हाँ प्रेशर ऑफ मॉडल दिया है, प्रेशर ऑफ प्रोटोटाइप पूछा है. ओके, सो आप क्या करोगे, पीपी को मल्टीप्लाई करोगे और 7.267 को इधर डिवाइड करोगे. So we'll have PP that equals to pressure of model divided by 78.267 whole bracket square. So यहाँ पे वैल्यू पुट कर दो. तो हमें 80 दिया था, 80 न्यूटन पर सेंटीमीटर स्क्वायर. सी यहाँ पे आप ऊपर 80 लोगे तो आंसर न्यूटन पर सेंटीमीटर स्क्वायर में आएगा. आप यहाँ पे 18 to 10 power 4 लोगे तो आपका आंसर न्यूटन पर मीटर स्क्वायर में आएगा. ओके, तो हम 80 ले रहे हैं, सो आंसर न्यूटन पर सेंटीमीटर स्क्वायर में आएगा. So finally, we will have pressure of prototype that equals to 0.03 01306 Newton per centimeter square. Okay, so with this problem, we had completed our unit number 6.